The simple understanding of this diagram is that uh, here we have the virus. Okay, so the virus is attached to the cell wall. So this black line represents the cell wall of the host cell. Okay, then this capsid, okay, this capsid, okay, during fusion is the one that is released inside the host cell. So this yellow part here is the capsid. Okay, so the capsid carries the DNA information, also the RNA information of the HIV virus. Okay, it carries the DNA material, okay, or the RNA material of the virus. So these will be released. So we have the HIV RNA. So when this HIV RNA has been released, with the help of the reverse transcriptase. Okay, so this arrow is showing that with the help of reverse transcriptase, the HIV RNA will be converted into the HIV DNA, or it will be synthesized to come up with the HIV DNA. Okay, so this is a DNA component or material. So HIV, so the RNA is one strand, okay? So when a DNA material has been formed, it becomes double-stranded, okay? So we have the HIV double-stranded DNA material. So now when it reaches the nucleus, entering the nucleus, okay, when it enters the nucleus, so in the nucleus, that is where we have the host DNA, which is formed. So in the host nucleus, okay, of course, this black line is indicating the nucleus. So in the host nucleus, the double-stranded HIV DNA material is going to be incorporated to the host DNA, okay, using the enzyme integrase. So reverse transcriptase here changing the HIV RNA to a double-stranded HIV DNA. Okay, then we have integrase in the nucleus here, combining the new formed HIV DNA material into the host DNA. So when you look at this part here, okay, it's different from this host DNA material, which is yellow, okay, in this representation. So there is insertion of the host into the host genome, okay, of this virus. So when this has been done, so this DNA material will be influenced to produce HIV messenger RNA. Okay. So when these HIV messenger RNA are produced, so we have these HIV messenger RNA. Okay, they will come out. Okay, and as they come out, they find other proteins within the cytoplasm. Okay, of other protein materials that are needed for the virus. So with the help of the protease enzyme, it is going to cut long HIV proteins, okay, into HIV precursor proteins. So here at the bottom of the cell, we have HIV longer proteins, okay, that come out from there. So when the protease enzyme works on these HIV proteins, it's going to cut them into smaller ones that are needed for the virus. Okay, so now the the HIV RNA that has now been produced is going to assemble with the HIV precursor proteins here to form new virus. So when the new virus has been formed, then it buds out here, okay, as a new virus by acquiring an envelope. Okay, so that is how the HIV virus necessarily replicates. So when we are trying to block in pharmacology, okay, we bring in some inhibitors here to stop fusion or to stop attachment, okay? Or if here the virus has entered, we can use non-reverse transcriptase, nucleoside reverse transcriptase inhibitors. So here, so nucleoside is a protein material that is needed for DNA. So we can try to block this conversion of HIV RNA to HIV DNA. If we fail to block this, we can try within the nucleus to block the combination of HIV DNA material into the host DNA by building a drug known as an integrase inhibitor. Okay, so if it fails here, then we can also try to stop the proteins, the conversion of HIV long proteins into HIV precursor proteins by coming up with a protease inhibitor, okay, drug here, okay. So that is how now the virus, after it being released here from the nucleus, it comes into the cytoplasm here of the cell. We have the precursor, then there is assembly, then there is a movement out of the or budding out of the virus, budding out of the virus. So that is how we should understand the steps here of the virus and also the pharmacological actions that are supposed to be done